അതായത് ലെഫ്റ്റ് എന്നോ റൈറ്റ് സിബ്ലിംഗ് എന്നോ എടുക്കാം. അപ്പോ അതിലാണ് നിങ്ങൾക്ക് സ്യൂട്ടബിൾ അതെടുക്കും. അതായത് ലെഫ്റ്റ് സിബ്ലിംഗ് എടുക്കണമെങ്കിൽ ലെഫ്റ്റിൽ എന്ത് വേണം? മോർ ദാൻ ദ മിനിമം നമ്പർ ഓഫ് കീസ് വേണം. റൈറ്റ് സിബ്ലിംഗ് എന്ന് എടുക്കുന്നതെങ്കിൽ റൈറ്റിൽ എന്ത് വേണം? മോർ ദാൻ ദ മിനിമം നമ്പർ ഓഫ് കീസ് വേണം. ഓക്കെ, സോ ആ ഒരു കേസ് എങ്ങനെ ഹാൻഡിൽ ചെയ്യുമെന്ന് നമ്മൾ പറഞ്ഞു. ഓക്കെ, സപ്പോസ് ലെഫ്റ്റ് ഞാൻ പറയുന്നത് എങ്ങനെയാണ്, സപ്പോസ് എൻ്റെ ലെഫ്റ്റില് ഇവിടെ മോർ ദാൻ നമ്പർ ഓഫ് കീസ് ഉണ്ടെങ്കിൽ ഞാൻ എന്ത് ചെയ്യണം? ഏത് കേസ് അപ്ലൈ ചെയ്യണം? ഞാൻ എന്ത് ചെയ്യാന്ന് വെച്ചാല് മെർജ് ചെയ്യാം. അതായത് എൻ്റെ ലെഫ്റ്റ് സിബ്ലിംഗുമായിട്ടുള്ള നോഡിനെ മെർജ് ചെയ്യാം. എന്നിട്ട് എന്ത് ചെയ്യാം? പാരന്റിനെ ഇതിലോട്ട് ഇൻക്ലൂഡ് ചെയ്ത് നമ്മൾ കഴിഞ്ഞ ക്ലാസ്സിൽ ഡിസ്കസ് ചെയ്തിട്ടുണ്ട്. അതായത് മെർജ് ചെയ്തിട്ട് പാരന്റിനെ ഇൻക്ലൂഡ് ചെയ്യിക്കണം. ഇതുണ്ടോ, ഈ കേസിൽ പാരന്റ് ഉണ്ടാവും. എന്നിട്ട് ഈ കീനെ ഡിലീറ്റ് ചെയ്യാം. അതിനുശേഷം പോയിന്റേഴ്സിനെ റീഅറേഞ്ച് ചെയ്യണം. സോ ദിസ് ഇസ് ദ മെത്തേഡ്. അപ്പോ previous class we discussed this case. Okay, here what happened is that so this is one case. Okay, this is this case. Okay, borrow from immediate left sibling. We performed borrow from immediate left sibling. So sorry, this is case 1B. If the we can borrow, then borrow from the immediate left sibling. Then this is the procedure. Largest key from the left sibling moved to parent node, and parent key is moved to leaf node. This is that procedure. If the left sibling or if the left sibling having more than the minimum number of keys. That is one case. Next case is similar case is there. That is, sometimes I can borrow from the immediate right sibling. In that case, what we want to do? We want to find the minimum key. Minimum key from the right sibling move to its parent node and parent node. That case also is there. So the next case is this is another case. Okay, case 1B, unable to borrow from left or right sibling. In that case, what we want to do? We want to merge with the left or right sibling. Okay, then include a parent of sibling leaf node in it. Then delete the key. Then rearrange the pointers. This is the okay. So we performed this and this yesterday we discussed this case. Okay, so but the problem is after doing this operation, still this key this tree or this node, okay, this node violate the property. Because why? Because only one key in this. Okay, it is not possible. Minimum 2 keys are needed. So we need to again rearrange. Okay, we need to handle it. Okay, how it is handled? How it is handled? Here, just note this case. Here, 20 violates B-tree property. Then it asks for a key. So what it will do is that it first retrieves the sibling. Okay, then it asks for a key from right sibling. Here 20 is here. He asked to its right sibling. Only one sibling is there, immediate right sibling. Okay, so there is no left sibling. So only option is to ask to the immediate right sibling. Okay, so but the problem is the right sibling, but it's not more than the minimum number of keys. Okay, this is the problem. Okay, that is the this also having not more than the minimum number of keys. Okay, only 2 keys, so I can't borrow it from. So what I will do, then I will ask it to from the parent. Okay, then I will request a key from the parent. Just try to understand that procedure. Then it asks for a key from its parent. Okay, then it for a key from its parent. അതായത് എന്ത് ചെയ്യാം, പാരന്റിനോടൊന്ന് ചോദിച്ചു. അപ്പൊ പാരന്റ് എന്ന് വെച്ചാൽ ഈ കേസിൽ എന്താണ്, റൂട്ടാണ്. ഓക്കെ, അപ്പൊ നിങ്ങൾ ഇവിടെ ശ്രദ്ധിക്കേണ്ട കാര്യം, B-treeയുടെ കേസിൽ റൂട്ടിൽ മിനിമം നമ്പർ ഓഫ് കീസ് 1 ആണ്. ഓക്കെ, സോ റൂട്ടിനോട് റിക്വസ്റ്റ്, since it is a root, it will give one key, which is 50. Okay, root gives the key 50 to L. So then what will happen here? In the previous written wrong way. Okay, this is actually wrong, and what will be the character representation? 50 is given to this node. Okay, so what will happen? Here 50 will come. Okay, here 50 will come. Then here 50 will come. Okay, this is 50 actually. Okay, this is 50. Then 50's, if we compare it, this child. Okay, 50's right child is there. Okay, you can note here 50 is moved from this position. 50 is moved from this position to this position. So what about these childs 70 and 72? So what we will do, we need to attach this. Okay, 70 and 72 I want to attach here. Okay, I want to attach 70 and this is 70. Then similarly I want to 72, 70 and 72. This is a node having two keys, one is 70 and 72, and this is not needed actually. This is not needed. This is not needed. So the final tree will be like this: 80 is here, 20 is here, 50 is here. Then the right child of 50 is 70 and 72. In this, we want to reorganize the tree. So try to understand that concept. This 50 is moved to this position. Then the right child, this child of 50 should be rearranged. That be done in this way. So try to do some questions, then you will get that idea. Anyway, the basic concept is we need to keep the B-tree property always. Okay, if B-tree property is violated, we should rearrange or reconstruct the B-tree property. Okay, so next is, what is case 2? What is case 2? Case 2 means a key internal node. Okay, so the key is in the internal node. Then what is we need to apply case 2.a. If case 2.a is, we need to apply case 2.b. If case 2.b is failed, we need to apply C. Okay, so okay. Okay. We need to apply case 2.c. So what is the first case? First, find the in-order predecessor. Okay, find the in-order predecessor. Okay, so if node having in-order predecessor having more than the minimum number of keys, if there is a in-order predecessor node then having the more than minimum number of key, then target key is replaced with the in-order successor. So that is a very simple case basically. Okay, so our device is an in-order predecessor. Okay, what is in order predecessor? So that is very important. What is in order predecessor? That is the last key in the left subtree of, and I am writing here. You should always remember this. What is in order predecessor? In order predecessor. Okay, this is very important concept. Without knowing this concept, you can't solve problems. Okay, so in order predecessor means largest key in the left subtree. Okay, subtree. Predecessor of, suppose n. N is the node. Then largest key in the left subtree of n is called the in order predecessor. Okay, so in this case, for example, consider this case. I want to delete 95. Okay, I want to delete 95. 95 is which type of node? 95 is an internal node. Okay, so I am trying to apply the case 1. What is the in order successor? Here, who is the left child of 95? This one. Okay, this is the left or left subtree. Okay, only one child is there in the left subtree. Largest key is 93. Okay, largest key is 9. So, who is the in order successor here? 93 is the in order successor of 95. Okay, so try to understand what is in order order predecessor. Okay, what is in order predecessor? So largest key in the left subtree. Okay, in order predecessor means largest key in the left subtree. So in this case 9. But what is the problem? How many keys are in this leaf node? In this leaf, 2 keys. I can't borrow some. Okay, so going to the explanation. Here, the in order predecessor is 93, but key containing node having no more than minimum number of keys. Only 2 keys are here. So I can't replace. I can't replace the target 95 with 93. Okay, so what I will do? Which means which case is failed? That is case 2.A is failed. Okay, then what I want to do? I want to move to the case 2.B. Okay, then I want to find the in order successor and then go to the case 2.
Sir, leave I could leave one.
Okay, leave I.
Okay.
Chat box attendance chat box leave.
Okay, sir.
Okay. So this is case 2.B. Okay, case 2.B. Okay, case 2.B. So what is case 2.B? Then find the in order. Okay, so what is in order successor means? ആയിരിക്കും പറയാൻ പറ്റുമോ? എന്തായിരിക്കും in order successor? In order predecessor നേരെ ഓപ്പോസിറ്റ് ആയിരിക്കും എന്ത്? In order successor. ഓക്കെ, വളരെ ഇമ്പോർട്ടൻ്റ് ആണ്. അതുകൊണ്ടാണ് അത് പെട്ടെന്ന് പറഞ്ഞു തരുന്നത്. In order successor മീൻസ് എന്താണ്? ഇപ്പൊ ഒരു നോഡ് ഉണ്ട്, ആ ഒരു നോഡിന്റെ in order successor എന്ന് വെച്ചാൽ എന്തായിരിക്കും? അതിന്റെ റൈറ്റ് സബ്ട്രീ നോക്കുക നിങ്ങൾ. റൈറ്റ് സബ്ട്രീയിലെ മിനിമം വാല്യൂ ആയിരിക്കും എന്ത്? In order successor. Minimum key in order successor. Okay, so what is in order successor? Important in order successor. Okay, so find the in order successor node. It having more than the minimum number of keys, then target key is replaced with in order successor. Okay, that is the case 2.b. Let us check whether it is possible or not. Okay, in this case, so take it. We stopped here. So we check for in-order successor. In this case, who is the in-order successor? It is 100. Why it is 100? This is the right subtree. Only one child. Okay. So, and the minimum value is 100. 100 is the in-order successor. Okay. So, how many keys are in this? 3. Okay. So, more than the minimum number of keys. 2 is the minimum number of keys needed. More than 2 is there. Okay. So, what I can do? I can replace 95 with 100. Okay, it's simple case. Simple case. Okay. So this is 100, 110, 11 having more than the minimum number of keys. So what I will do, I just replace with this. That is also very simple. Okay. Basically, these cases are simple. Only confusion will come what is in order successor and in order predecessor. So I told what is in order predecessor, what is in order successor. Okay. Then replace the keep the in order replace the key node to be deleted with the in order successor or in order predecessor. That is the simplest case. Okay. So this is case this will do, and just note this what is in order predecessor and what is in order successor. Okay. So in the university exam they will check your knowledge in this area. Sure, they will check this knowledge. Okay, so in order predecessor and in order successor is very important. It's very important. Okay, so this is the resulting tree. Okay, this tree doesn't violate the B tree property because the root having one child, one key, it having two, minimum 2 and maximum 4 keys are allowed 2, and this also satisfies. So this is also a bit. Okay. Now we discussed case 2.A and case 2.B. Now what is case 2.C? Let us go to an example, and here this is the case. Suppose I want to delete 100. Okay. So where is 100? Where is 100? 100 is this. Okay. Here 100. 100 is in which node? Internal node. Okay. So what I want to do is that I want to delete 100. So what is the procedure? What is the procedure? Using the same procedure I applied. I checked the case 2.A, case 2.B, and case 2.B. Okay. But what's the problem here is that in this case, go to the explanation. In this case, I want to delete 100 from here. To delete 100 from here. But what happened is that I want to delete 100 from here. Okay. So what is our procedure? I want to delete 100. Then what I will do? Which case I will apply? It is an internal node. And next I will check case 2.A. So find the in order predecessor. If node having in order predecessor more than, then I will replace it. So in this case, this is 100, 110, and 11 having, okay, sorry, this is not this case. This is the case. Delete 100. Delete 100. So what I will do is that 90. Okay. So here the node is 90. 1 minute.